Alright, so I'm going to teach you guys how to do problem 15 on expert TA, which, I don't know, we're stupid and we chose it, but it's the hardest problem and it's really dumb. So basically, the problem tells you that we're trying to find the angle of this man who's shooting a basketball into a 3.05 meter hoop, and he's 2.44 meters tall, and then your change in x between both is 4.57. So basically, we're going to start with our givens table, which basically you don't know VI or VF, but since you know that A is going to equal 0 on the x side, and you know that A is going to equal negative 9.8 meters on the y side, and they give you change in x equals 4.57. And then you can find change in y because you basically just do 3.05 meters minus 2.44 meters, and that's going to bring you to a total of 0.61 meters. So those are the givens. Those are all the givens. And then basically, since you're trying to find the angle here, which is theta, you're going to create a triangle much like all the others, except this is what you're trying to find. So normally you derive VIY and VIX by using angle of theta and VIY. And oh, I forgot to tell you that this number is 7.157. That's the velocity that he's shooting the basketball at. So basically, since you don't know the angle, your initial velocity of y and initial velocity of x are going to be abstract. So they're going to be 7.157 sine of theta is going to be the initial velocity of y.
Everyone listen up. We gotta be quiet. We have a couple people quizzing, so if we could just make it, you can still talk very quietly, but not big conversation. So if you're gonna talk.
And then the initial velocity and final velocity of x are just going to be cosine. Because since sine is opposite over adjacent, that's going to be your sine. And this is going to be your cosine because it's adjacent over hypotenuse. So basically, now you have all your givens, so you can proceed to find change in t, which normally you could derive from kinematics. But since you don't have enough equations on this side, or enough givens, you'd use velocity equals change in x over change in t to find your change in time. So you have 7.157 cosine theta equals 4.57, because that's your change in x. And then, my bad. This is your velocity over change in t. And then you just have change in t equals 4.57 meters over 7.157 cosine of theta. So then basically you're going to have to substitute t in to one of the kinematic equations to try and find it. So that's going to be the kinematic equation you're going to use is change in x equals vi change in t plus 1/2 acceleration change in t squared. And when you substitute that in, it's going to be 0.61 equals 7.157. Oh, sorry, this should be changing more. 0.61 equals 7.157 sine theta times, and you're going to sub in t here, so it'll be 4.57 over 7.157 cosine theta plus, and then if you simplify it, it's just, oh no, sorry, that should be minus. So if you simplify 1/2 and the acceleration, which is just negative 9.8, it's negative 4.9, and then you sub in t squared again, which is 4.57 over 7.157 cosine theta squared. And then basically you're just going to continue to simplify this, so it's going to be 0.61 equals, oh yeah, and here you can start simplifying, so you can cross out 7.157 because they just cancel, and then sine over cosine would just equal tangent using your trig identities, so you'd be left with 5.57 tangent theta minus, and then you multiply these out and it'll be 102.336 over 51.226 cosine squared theta. And this is that. And then basically you could keep simplifying it. Here, sorry, I'm going to go over here. Into 0.61 equals 4.57 tangent theta minus, and this simplifies pretty easily, it's just 2 over cosine squared theta. And then I'm going to have to flip this over because we don't have enough. Actually, you know what, I can keep writing on it. Alright, so if you keep simplifying, you're going to have 0.61 equals 4.57 tangent theta minus 2 secant squared theta, because that's another trig identity. It's just that cosine squared equals, oh my bad, it would be 1 over cosine squared theta is the same as secant squared theta. That's what that equals. So then you can keep simplifying into 0.61 equals 4.57 theta. And since we want to keep this equation in like all tangents just to make simplifying even more easier, you'd be left with 2 times 1 plus, sorry, that should be 2 times 1 plus tangent squared theta. Because if you look up here at trig identities, which you can find online or basically anywhere, you can be left with secant squared equals tangent plus 1 squared, if you would just move this to the other side. So then you can keep, actually, then you start distributing, and you're left with 4.57 tangent theta minus 2 tangent squared theta minus 0.61 equals 0, because at this point you're just trying to get, you're distributing and putting everything on one side of the equation, so you're just left with 0 on this other side. So then you just add like terms, so 4.57 tangent theta minus 2 tangent squared theta, shut up Thomas, minus 2.61, because here it's the same exact thing, but you just combine negative 2 and negative 0.61. So at this point it's a bit confusing, but basically the equation is now a polynomial. And then in the sense that the polynomial is a squared plus ab plus c. And you see this, that it's 2 tangents squared, and then a regular tangent, and then just a constant. So you're left with that squared, non-squared, and then a constant. So here you can continue simplifying into the quadratic equation, which I know is really stupid. But you have to do negative 4.57, that's your b value, plus or minus square root of 4.57 squared minus, and then you do 4ac, which is 4, negative 2 is your a value, and negative 2.61 is your c value, all over 2 times your a value, which is negative 2. And then you have to keep simplifying, so I'm out of room and I need to erase all this. Yeah, I know. I need Clorox. Alright. So, I'm just going to bring that back up here. So then you get negative 4.57 plus or minus square root of, if you, and then 4.57 squared is 20.8849 plus 4 times negative 2 times negative 2.61 is negative 20.88, and that just cancels. So that'll end up being square root of 0. All over 2 times negative 2 is negative 4. So then you're left with negative 4.57 plus or minus square root of 0 over negative 4
You'll get the same answer
equals, and then if you just put all that in a calculator, you're left with 1.425. And that's going to end up being your theta value, actually. So, how do you do this tan inverse part again? It's, oh yeah, since everything was in terms of tangents earlier, which I just erased, which kind of sucks, you basically just do